the standard.
Okay, we can make one simple, really simple example to illustrate, how that works. And let me just make sure that the recording is working. Yep, it is working.
Because the parameters look exactly the same, but you said if you run them, they should come up with different values.
Mm-hmm.
And I keep trying, but I keep coming up with the same values.
The two invocations came up with the same value?
Yeah.
Okay.
Yeah, when going through it again, the x is the same value because you're returning.
Oh, because it's reset again.
Yeah.
I forgot about that because you hit the end, every single time, and that's why they end up with the same value.
Yeah.
Okay, very good. Wow, I'm impressed. Because not only do you guys realize they return the same value, you also found out why it is returning the same value. It's because at the very end, you reset x to a specific value. So when you backtrack, when you go back, it only changes it in a certain way. Very good. Well, I'll just keep the homework assignment the way it is. In other words, it will return the same value, even though in both occasions we're changing something, but it changed again every time we hit the what we call a base case. Let me just go look at the homework assignment so I can tell you guys exactly why, or point out to the statement where.
I think it's okay.
Yeah, we are going to open it up and take a look.
Thank you very much.
Oh, thank you for bringing it up. Okay, so the thing has to do with.
No.
That's not the one.
No, on line 5 I was saying because it returns the same as on line 8.
Yeah.
Line 5 and line 8.
Yeah, because until line 8 it increments by 1, and then line 5 is still the same.
Oh, there are occasions where they can possibly return. They cannot return the same value. Well, okay, it depends. If you encounter this case first, then it will return, and then when you encounter the other case, then it will return the same value. Yes. Yep. Mm-hmm. But in that case, okay, remember what we talked about? I did not say that the invocations would not return different values. I talked about how if you use the same n, it may return a different value. That was what I said. Okay, but in your case, they return the same value because in one case n is 0 and in the other case n is 1. Okay, so which is opposite to the point that I want to make. Okay? No? Okay, the point that this program is trying to make is if you try to call or invoke S4 with the same value given to n, those two invocations can return a different value. Now, when you guys realize they're returning the same value, you are basically saying that when n equals to 1, it returns a particular value. When n equals to 0, it returns the same value. So the question is, what if in both cases n equals to 1? Okay, if you have two invocations where n equals to 1, they will return a different value.
Oh yeah.
Yep, and that was the point. That was the whole point. Because, okay, so your observation was correct, because, and when we specified 2 to here, okay, let's just take a look at this, in a more graphical way. So this way we can talk about, okay. So initially n equals to 2, that's the first invocation. When n equals to, it will go ahead and do the recursion. That is on line 11. On line 11, it will trigger 2 additional invocations. The first one is when n equals to 1, because the first recursive call will pass n minus 1 to n, which means n equals to 1. So this will be handled first, and in that case, x gets incremented and then it gets returned. The second case is when n equals to 0, and in that case, we don't increment anything, and as a result, the same x got returned. And that's why what you saw was this invocation returns a particular value, and this invocation returns exactly the same value. Is that what you're trying to say? Okay. Now, but you can try this also. Just try to invoke S4 twice, and each time using n equals to 1, and they will not return the same value. And that was the point that I was trying to make. I did not make this example big enough. Remember I said let's make n equals to 3 initially so that it is not too tedious. Because if you make n equals to 3 to begin with, then the first invocation will be n equals to 2. The second invocation will be when n equals to 1. And in this case, this value that is returned will not be the same as that value. So these two return values would not be the same anymore. Even though in both cases you invoke the subroutine with n equals to 1. Okay? I'm not changing the homework assignment, so don't worry. Okay, you don't have to do it all over again. I'm keeping it exactly the same way. But as a test or as a not as a test, as an exercise that is not graded, change the program so that instead of using 2 here, use 3. Okay, and then you can see that there will be 2 cases where you will invoke S4 with n equals to 1, and in the first one it will return a particular value. In the second one it will return a different value. Yep, go ahead.
I want to ask, well, if it's going to be 3, it's never going to be 0. It's never going to get to 0. It's going to be 3.
It will. Because if it's 3 to begin with, then the first invocation will trigger these 2 invocations. The second invocation will trigger these 2 invocations, which you already know how to deal with. But from the first invocation, it will just invoke S4 one more time with n equals to 1. So it will terminate. It will finish. It's just that the first time you invoke with n equals to 1, the return value will be different from what it returns the second time you invoke S4 with n equals to 1. Yep.
When we open a new return line number, do we have to put the value that is being referenced? We never update it, so do we have to put it there? Do we update the original one?
You mean parameter x in this case? Are you talking about a column that will represent parameter x?
The first one we keep, but the other ones, do we keep opening those up?
Yes. Each time you invoke S4, you have to allocate a new column for its own parameter x.
And we don't update those?
They will all be referring, in this case, in this very specific case, they will all be referring back to the same column, yes. But you still need to allocate those columns because parameters are done or allocated on a per invocation basis. So every time you invoke the subroutine, whether it's recursive or not, every time you invoke the subroutine, you need to allocate those columns.
I was confused because when I was tracing this out, I kept moving over to the right-hand side. And every time the value being referenced was updated, I had to move all the way here and update this column.
That is exactly what you have to do. Because whenever you update, like in this statement and also in this statement here, okay, let's just take a look at these 2 statements. Both of these statements will update x, right? And x is passed by reference. In other words, in both statements, on line 7 as well as line 10, you have to change the column referred to by parameter x. And that's right. That means you have to scroll all the way back to the left-hand side of the spreadsheet to update a column whenever you execute line 7 as well as line 10. Okay.
So when we pass by reference for x, we're not passing a value, we're passing
by reference.
the column.
We are passing how to find an original item. Which
But if we change x, how can we reference it?
we're not changing the reference to x. We're not changing the reference itself. We're changing what it is referencing. So if x reference, say column E, whatever it is, then every time you change x, column E gets updated, not parameter x itself.
Okay. Thank God I did that.
Okay.
And you're saying that every time we start a new invocation, we need to carry that X column, even though it's always referring back?
Yes.
Okay.
Yep, because that's exactly what happens when you run this program with a real programming language. That's exactly what's going to happen.
Okay.
Parameters, by val and by ref, as well as local variables, they're all allocated on a per invocation basis. So every time you invoke, the subroutine, you have to do it. Whether it's recursive or not is not important. Okay. Any other questions about this one?
Can you still do a simplified example of line 11 where it shows?
Of line 11.
Yeah, because
Okay.
I came up with the same value, and you said you can get different values, and I know you kind of explained it, but it's still not clear.
It is supposed to return the same value simply because I did not give you a big enough n so that you can actually see the difference. I gave you an n which is 2, which is kind of like a minimum n, and that's why in this specific case these two values that are returned are going to be exactly the same.
Can you make a simplified example where I can see where they're not the same?
Well, yes I can. If you don't want them to be exactly the same, the quickest and easiest way is to get rid of this case here. If you get rid of that, then you will see that it will have one more level of invocation because we are not stopping when n equals to 1. And you will see that if you do this, you will see every time it returns, it will return with a different value.
Okay.
Okay, so I cannot do it here because that would just kind of give away the solution a little bit too quickly.
No,
But I
that's
can.
why I wanted to make a simplified example, but that works.
Let me make a quick example. I think that's a valid request. So let's say define sub S5. This time all we do is passing by reference a particular something, and let's say we pass. Okay, let's resemble what we have to do in the other case. That'll make this one really simple. Okay, how about this? If n mod 3 equals to 0. So this would be a little bit different from the other ones that we have seen so far. In this case, it will return x plus 1. Let's do something with x first. N plus 1 works just as well in this case. And then we'll pass x to x. We'll just throw this in